Galaxies are the cities of the universe. Vast collections of stars, gas, dust, and dark matter, bound together by gravity, each one home to billions of worlds. But not all cities are built the same. Tonight, we explore the many shapes the universe gives its galaxies. When you look at a galaxy through a telescope, the first thing you notice is its shape. Some galaxies are beautiful, symmetric spirals with sweeping arms. Others are smooth, featureless blobs of golden light. Others are chaotic, messy, and impossible to categorize. The shape of a galaxy tells you something about its history, its age, and the forces that have acted upon it over billions of years. In the 1920s, the astronomer Edwin Hubble created the first classification system for galaxies. He arranged them into categories based on their appearance in a diagram that became known as the Hubble tuning fork. On one side, the spirals. On the other, the ellipticals. And in the middle, a transitional type called lenticulars. This scheme was simple, elegant, and still forms the foundation of galaxy classification today. But the universe is more creative than any diagram. Since Hubble's time, astronomers have discovered galaxy types that do not fit neatly into his categories. Ring galaxies, active galaxies, irregular galaxies, galaxies shaped by collisions, by mergers, by forces that Hubble never imagined. Let us visit each type one by one. Spiral galaxies are the most visually striking objects in the sky. They have a central bulge of older stars surrounded by a flat disk containing younger stars, gas, and dust. Sweeping out from the disk are the spiral arms, bright lanes of star formation that wind outward from the center like the arms of a pinwheel. The spiral arms are not permanent structures. Stars do not stay in the arms forever. The arms are density waves, regions of compressed gas that move through the disk like ripples on a pond. As gas enters a density wave, it is compressed, triggering the birth of new stars. The brightest, hottest, shortest-lived stars light up the arm, making it visible. But those stars burn out quickly, and by the time they die, the density wave has moved on. The arms glow because they're constantly forming new stars, not because the same stars stay in them. Our own Milky Way is a barred spiral galaxy. That means it has a bar-shaped structure at its center with spiral arms extending from the ends of the bar. About 2/3 of all spiral galaxies have bars, making them the most common subtype of spiral. The Andromeda Galaxy, 2.5 million light-years away, is also a spiral. It is the nearest large galaxy to the Milky Way and the most distant object visible to the naked eye. When you look at Andromeda on a clear night, you are seeing light that left that galaxy 2.5 million years ago, before humans had invented tools. Spiral galaxies tend to be rich in gas and dust, which means they are actively forming new stars. They are alive, in a sense, constantly building, constantly creating. The blue light of young, hot stars mixed with the red glow of hydrogen gas gives them their vivid, colorful appearance. Elliptical galaxies are the opposite of spirals in almost every way. They have no disk, no spiral arms. They are smooth, rounded collections of stars, ranging in shape from nearly spherical to elongated, like a rugby ball. Their light is dominated by old, reddish stars. There is very little gas or dust and almost no new star formation. Elliptical galaxies are, in a word, retired. They have used up most of their gas. The star-forming days are behind them. What remains is a vast, quiet collection of aging stars, slowly cooling and dimming over billions of years. But do not mistake quiet for small. Elliptical galaxies include both the largest and the smallest galaxies in the universe. Dwarf ellipticals, containing just a few billion stars, are the most common type of galaxy in existence. They are tiny, faint, and easily overlooked. At the other extreme, giant ellipticals can contain trillions of stars and span hundreds of thousands of light years. The largest galaxy known, IC 1101, is a giant elliptical about 6 million light years across, more than 50 times the diameter of the Milky Way. Most giant ellipticals are thought to have formed through mergers. When two large spiral galaxies collide, their orderly disks are destroyed. The stars are scattered into random orbits. The gas is either consumed in a burst of star formation or expelled entirely. What remains after hundreds of millions of years of gravitational settling is a smooth, elliptical galaxy. The chaos of the merger has been averaged out into a featureless, golden glow. The giant elliptical galaxy M87 at the center of the Virgo cluster is home to one of the most famous black holes in astronomy. The supermassive black hole at its center was the first ever to be imaged by the Event Horizon Telescope in 2019. It contains 6.5 billion times the mass of our Sun. A monster sitting quietly at the heart of a retired galaxy. Lenticular galaxies are the bridge between spirals and ellipticals. They have a central bulge and a disk like spirals. But they have no spiral arms. Their disks are smooth and featureless, with little gas or dust and almost no ongoing star formation. They look like spirals that have run out of fuel. The structure is still there, but the engine has stopped. Lenticular galaxies may represent a transitional phase. A spiral galaxy that has exhausted its gas supply or had its gas stripped away by interactions with other galaxies might fade into a lenticular. The arms disappear. The star formation ceases. And what remains is a disk of aging stars, orbiting quietly around a central bulge. They are sometimes called the forgotten galaxies because they receive less attention than the dramatic spirals or the massive ellipticals. But they are common, especially in dense galaxy clusters where interactions between galaxies are frequent. Irregular galaxies are the rebels. They do not fit into any neat category. They have no symmetric shape, no spiral arms, no smooth elliptical profile. They are messy, chaotic, and often strikingly beautiful. Many irregular galaxies are small. They lack the mass needed to organize themselves into a stable spiral or elliptical shape. Their stars, gas, and dust are distributed haphazardly, producing an appearance that looks almost accidental. The Large Magellanic Cloud, visible from the southern hemisphere as a fuzzy patch of light near the Milky Way, is an irregular galaxy. It is a satellite of the Milky Way, about 160,000 light-years away, and it contains a rich collection of star-forming regions, including the Tarantula Nebula, one of the most active star-forming regions in the entire local group. The Small Magellanic Cloud, its companion, is also irregular. Together, the two Magellanic Clouds are among the closest galaxies to our own, and they provide astronomers with a nearby laboratory for studying star formation, stellar evolution, and the dynamics of small galaxies. Some irregular galaxies are irregular because of collisions. When two galaxies interact, tidal forces can distort their shapes beyond recognition, pulling out long streams of stars and gas, creating bridges and tails that stretch across hundreds of thousands of light years. These interacting systems are some of the most dramatic objects in the sky. The antenna galaxies, for example, are two spiral galaxies in the process of merging. Their shapes have been pulled apart into long, curved tails of stars, giving them the appearance of insect antennae. Ring galaxies are among the rarest and most visually striking types. A ring galaxy forms when a smaller galaxy passes directly through the center of a larger galaxy. The collision sends a wave of compressed gas expanding outward through the disk, like a ripple from a stone dropped into a pond. This expanding wave triggers a burst of star formation, creating a bright ring of young, blue stars surrounding a relatively empty center. The most famous ring galaxy is Hoag's object, about 600 million light-years from Earth. It is a nearly perfect ring of bright blue stars surrounding a core of older, yellow stars, with almost no thing visible in between. It is so symmetric and so striking that when it was first discovered, astronomers were not sure what they were looking at. It looked almost artificial, almost designed. But it is a natural product of galactic dynamics, created by the same forces that shape every other galaxy in the universe. Ring galaxies are rare because the collision that creates them must be almost perfectly aligned. The smaller galaxy must pass nearly straight through the center of the larger one. A glancing blow would produce a distorted spiral, not a ring. The precision required makes ring galaxies uncommon, but when they do form, they are among the most beautiful objects in the cosmos. Active galaxies are galaxies with something extraordinary at their centers. A supermassive black hole that is not quiet, not dormant, but actively feeding on the gas and stars around it, producing enormous amounts of energy in the process. When material falls toward a supermassive black hole, it does not simply disappear. it spirals inward, forming a disk of superheated gas called an accretion disk. Friction within this disk heats the gas to millions of degrees, causing it to glow brilliantly across the entire electromagnetic spectrum, from radio waves to X-rays. The energy output from the accretion disk alone can outshine the entire galaxy. Some active galaxies produce jets, narrow beams of material launched from near the black hole at nearly the speed of light, extending for thousands or even millions of light years into intergalactic space. These jets are among the most energetic phenomena in the universe. They inflate vast bubbles of hot gas, push aside the intergalactic medium, and shape the environments of galaxy clusters. Quasars are the most extreme form of active galaxy. They are so bright that when they were first discovered in the 1960s, astronomers mistook them for stars. It was only when their enormous distances were measured that the truth became clear. These are not stars. They were the blazing cores of galaxies billions of light years away, powered by supermassive black holes consuming matter at prodigious rates. A single quasar can produce more light than an entire galaxy of 1 trillion stars. And yet, the engine responsible for all that light is smaller than our solar system. A compact disk of gas spiraling into a black hole, converting gravitational energy into radiation with an efficiency that no other process in the universe can match. Most galaxies, including our own, have supermassive black holes at their centers. But most of those black holes are currently quiet, not actively feeding. The Milky Way's central black hole, Sagittarius A star, is dormant. It is not producing jets. It is not outshining the galaxy. But billions of years ago, it may have been active. And billions of years from now, if new fuel falls toward it, it may wake up again. Every galaxy in the universe belongs to one of these families or to some combination of them. Spirals, barred spirals, ellipticals, lenticulars, irregulars, rings, active galaxies, quasars. The variety is enormous. And yet, they are all built from the same ingredients. Stars, gas, dust, dark matter, gravity. The difference is history. A galaxy's shape is the record of everything that has happened to it. Every collision, every merger, every burst of star formation, every interaction with a neighboring galaxy. The shape of a galaxy is its autobiography written in stars. Two galaxies that formed from identical clouds of gas 4 billion years ago could look completely different today, simply because one experienced a major merger and the other did not. One became an elliptical. The other remained a spiral. Same starting materials. Different lives. Different shapes. The universe writes billions of these autobiographies simultaneously, and no two are the same. The universe is full of cities. And every city tells a different story.